Good day, class. Today we will talk about mathematical induction. And it is a method for proving statements about natural numbers. We have three methods that we need to follow in solving mathematical induction. The first one is what we call verification. We need to make the statement true for the natural number 1. Second, assumption. If the statement is true for some number k, then it is also true for the next natural number k plus 1. That k plus 1 is also known as the induction. And third, we have the conclusion. The statement is true for all natural numbers. Let us proceed with the first example. We need to prove 5 plus 9 plus 13 plus ... plus the quantity of 4n plus 1 equals n times the quantity of 2n plus 3. We need to prove that the left side of the equation will balance to our right side of the equation. The first step that we need to do is to verify. And in verification, we have our basis n equals 1. We need to change all the values of n here with 1. If it will be true, then we will proceed with step 2. So this one, 4n plus 1 will be 4 times 1 plus 1. Will it be equal to 1 times 2 times 1 plus 3? Okay, let's compute. 4 times 1 is 4 plus 1. And then 1 times 2 times 1 is 2 plus 3. That is 5. 5 is equal to 5. Since our step 1 is true, then we need to proceed with our step 2, which is assumption n equals k. We need to change all the values of n here with k. That is our assumption. So the given will now become 5 plus 9 plus 13 plus ... plus the quantity of 4k plus 1 equals k times the quantity of 2k plus 3. That is our assumption, step 2. Next, let's proceed with the induction. We need to change all the values of n with k plus 1. Okay, so the equation will now be, we need to copy first this one. Copy 5 plus 9 plus 13 plus ... plus 4k plus 1 plus the next term here will now be k plus 1. All n on our given will be changed to k plus 1. So we have 4 times k plus 1 plus 1. Will it be equal to, change all the n here with k plus 1. K plus 1 times 2k plus 1 plus 3. So we need to prove if the left side and the right side of the equation will balance. Since by merely looking at our step 2, the left side of the equation, 5 plus 9 plus 13 plus ... plus 4k plus 1 equals k times the quantity of 2k plus 3, we will just change this one with the value of the right side of the equation on our step 2. So this will now become k times the quantity of 2k plus 3. Next, just copy this one. So we have plus 4k plus 1 plus 1 equals k plus 1 times 2k plus 1 plus 3. Next, let us simplify. So we need to distribute k with 2k and then with 3. So it will become 2k squared plus 3k. Then this part, simplify. So we add, so plus 4 times k, that is 4k. 4 times 1 is 4 plus 1. So just copy. Equals, so we have k plus 1 here, and then distribute 2 times k, that is 2k, 2 times 1, that is 2, plus 3. Simplify. Combine like terms. Bring down 2k squared, and then 3k and 4k similar, so we need to add. It will become plus 7k, and then our constants, let's combine 4 plus 1, that is 5. How about on the right side of the equation? So copy k plus 1. Combine our constant here, 2 plus 3, that will become 5. Next, copy the left side of the equation, 2k plus 7k plus 5 equals FOIL method. So let's distribute k times 2k, that is 2k squared. Next, k times 5, that is 5k. 1 times 2k, that is 2k. And then 1 times 5, that is 5. Next, simplify. So copy first the left side, 2k squared plus 7k plus 5 equals 2k squared. 5k plus 2k, combine like terms, that is 7k plus 5. The left side and the right side of the equation balance. And for our last step, for the conclusion, you need to write, this is the symbol for therefore. So therefore, the statement, you need to copy your given, this one. The statement 5 plus 9 plus 13 plus plus 4k plus 1 equals k times the quantity of 2k plus 3 is true for all natural numbers n. That is how to prove the given statement using mathematical induction. Again, you need to verify, use n equals 1 as your basis. If it became true, then proceed with step 2. Change all your n with k. And then, for the step 3 induction, change all the n with k plus 1. And of course, do not forget your conclusion. Let's proceed with our second example. We need to prove that 1 plus 2 plus 3 plus ... plus n equals n times the quantity of n plus 1 over 2. The first step that we need to do is to verify. And in verification, we have our basis n equals 1. We need to change all the given n here with 1. And let's check if they will balance. So we have, on the left side, we have 1. Will it be equal to 1 times 1 plus 1 over 2? 1. Will it be equal to 1 times 2 over 2? 1 equals 1. Since the first step is true, we can proceed immediately with our second step, the assumption. And for assumption, we need to change all the n with k. So change all the given n here with k. So it will become 1 plus 2 plus 3 plus ... plus k equals k times k plus 1 over 2. That is our assumption. Next, proceed with the induction. And for the induction, we need to change our n with k plus 1. So k plus 1 will move after k here. So copy first this one. We have 1 plus 2 plus 3 plus ... plus k, and then plus, for our given, and it will now become k plus 1. So k plus 1 here equals, for the right side, change all the n with k plus 1. K plus 1 times k plus 1 plus 1 over 2. Instead of writing these long steps here, by merely looking at our assumption, the left side of the equation here is the same with the right side. So instead of writing this one as a whole, we will just copy the value of the right side from our assumption. So this will now become k times the quantity of k plus 1 over 2. Next, bring down plus k plus 1 equals k plus 1 times k plus 2. 1 plus 1, that is 2, over 2. Next, let us look for the LCD of this one, and we know that there is an imaginary one here, and the LCD is equal to 2. Very good. So we have 2. 2 divided by 2 is 1. I repeat, 2 divided by 2 is 1 times the numerator. It will become k times k plus 1. Next, 2 divided by 1 is 2 times k plus 1. That is 2k plus 1. Then copy the right side. K plus 1 times k plus 2 over 2. Since the denominator are the same, let us focus on the numerator and see if they will balance. So let us now distribute these terms. We have k times k is k squared. K times 1, that is k. Plus 2 times k is 2k. Plus 2 times 1 is 2. Same here, FOIL method. K times k, k squared. K times 2, that is 2k. 1 times k is k. 1 times 2 is 2 over 2. Now let us simplify. We have k squared. They are similar. So k plus 2k is 3k. Copy the constant 2. Next, k squared, 2k plus k, that is 3k plus 2. And they are balanced. Let's proceed with our conclusion. Therefore, the statement 1 plus 2 plus 3 plus ... plus n equals n times the quantity of n plus 1 over 2. You copy this one. is true for all natural numbers n. That is how to solve for the given statement. So let's recall. First, basis step. If the left and right balanced, proceed with our step 2. Change all your n with k. Next, change all your n with k plus 1 and then prove it if the left and right side will balance. If they balance, then do not forget your conclusion. Let's proceed with example number 3. Prove 2 raised to 3 plus 4 raised to 3 plus 6 raised to 3 plus ... plus the quantity of 2n raised to 3 equals 2n raised to 2 times the quantity of n plus 1 squared. Okay, again, our basis n equals 1. So change this with 1, our n. Same with the left side of the, right side of the equation. So we have 2 times 1 cube, 2 times 1 squared times 1 plus 1 squared. So 2 times 1 is 2, cube, that is 8. Will it be equal to? 1 squared is 1 times 2 is 2 times 1 plus 1 is 2 squared, that is 4. 8 is equal to 8. Step 1 is true. Proceed immediately with our step 2. Change all the n here with k. So we have 2 cube plus 4 cube plus 6 cube plus ... plus 2k cube equals 2k squared times the quantity of k plus 1 squared. That is our assumption. Next, letter C. For our induction, change all your n with k plus 1. So we have here, copy this one first. 2 cube plus 4 cube plus 6 cube plus ... plus 2k cube plus, this will now be changed with k plus 1. So we have 2k plus 1 cube equals, all the k here will be k plus 1. 2 times k plus 1 squared times k plus 1 plus 1 squared. Next, we know that these terms are the same with this one. So we will just change it with that. So it will become 2k squared times the quantity of k plus 1 squared, and then add this plus 2k plus 1 cube equals, copy, 2 times the quantity of k plus 1 squared, and then simplify k plus 1 plus 1, that is k plus 2 squared. Next, we need to factor out 2 here and k plus 1. So it will become 2 times the quantity of k plus 1 squared times k squared plus 2 squared times k plus 1 equals, copy, 2 times the quantity of k plus 1 squared times k plus 2 squared. Next, simplify. We have 2 times the quantity of k plus 1 squared times k squared. 2 raised to 2 is 4. So 4k, 4 times k, and then 4 times 1, that is 4. will it be equal to 2 times the quantity of k plus 1 squared times k plus 2 squared. Next, simplify again. We have, to get the factors of this one, we have 2k plus 1 squared, copy. Get the factors, we have k plus 2 squared. If you will use the FOIL method, you will get these terms here. And they equaled with our right side of the equation, 2 times k plus 1 squared times k plus 2 squared. Since they are equal or balanced, do not forget your conclusion. Therefore, the statement, you can copy the given, this one. The statement is true for all natural numbers n. And that is how to solve, how to prove our third example. Okay, do not forget to apply your knowledge in algebra in solving this one. Another example. Let us prove 1 plus 3 plus 6 plus 10 plus ... plus n times the quantity of n plus 1 over 2 equals n times the quantity of n plus 1 times the quantity of n plus 2 over 6. First, we need to verify, and for verification, we have our basis n equals 1. We need to change all the n here with 1, and let's see if they will balance with the right side of the equation. So we have 1 times 1 plus 1 over 2. Will it be equal to 1 times 1 plus 1 times 1 plus 2 over 6? So simplify. We have 1 plus 1, that is 2, times 1 is 2, divided by 2 is 1. And then 1 plus 1 is 2, times 1 is 2. 2 times 1 is 3. So 2 times 3 is 6, divided by 6 is 1. Since it is true, let's proceed with our assumption. N equals k. We need to change all the n here with k. So we have 1 plus 3 plus 6 plus 10 plus ... plus k times k plus 1 over 2 equals k times k plus 1 times k plus 2 over 6. This is our assumption. Next step is our induction. Change all the n with k plus 1. So copy first this one. It will remain, and then for the additional term, change it now with k plus 1. 1 plus 3 plus 6 plus 10 plus ... plus, copy this one, k times k plus 1 over 2 plus, then change this one with k plus 1. K plus 1 times k plus 1 plus 1 over 2 equals, all the k here will be k plus 1. So k plus 1 times k plus 1 plus 1 times k plus 1 plus 2 over 6. Okay, don't worry. We'll get there. Next, we all know that for our assumption a while back, the left and the right side are equal. So instead of writing this whole thing, for the next step, we will just change it with this one. So we have k times k plus 1 times k plus 2 over 6 plus k plus 1, and then just simplify. 1 plus 1 is 2. We have k plus 2 over 2 equals, so we have k plus 1. 1 plus 1 is 2, so we have k plus 2. And then 1 plus 2 is 3, so we have k plus 3 over 6. Next, we need to look for the LCD of 6 and 2. And we know that the LCD is, very good, 6. So let's divide. 6 divided by 6 is 1 times the numerator. So copy. Next, 6 divided by 2 is 3 times the numerator. We have 3, k plus 1, k plus 2. And then copy this one. We have k plus 1 times the quantity of k plus 2 times the quantity of k plus 3 over 6. Next, we need to factor out k plus 1 and k plus 2. So this will be cancelled. And what's left will now be the quantity of k plus 1 times the quantity of k plus 2, and of course, the quantity of k plus 3 over 6. The left side of the equation balance with our right side. Next step is to write our conclusion. And for our conclusion, we have, therefore, the statement, you can copy the given here, the statement is true to all natural numbers n. That is how to solve and prove our fourth example. Okay, let's proceed with our fifth example. We need to prove 1 cube plus 2 cube plus 3 cube plus ... plus n cube equals n squared times the quantity of n plus 1 squared over 4. Again, we need to verify, and our basis is n equals 1. We need to change all the n here with 1. So we have 1 cube. Will it be equal to 1 squared times 1 plus 1 squared over 4? So 1 cube, that is 1. 1 squared is 1. And then 1 plus 1 is 2. Squared is 4. Over 4. So 1 is equal to 1. Since it is true, let's proceed with our step 2, assumption. Change all your n with k. So we have 1 cube plus 2 cube plus 3 cube plus ... plus k cube equals k squared times k plus 1 squared over 4. After writing your assumption, let's proceed with our induction. We need to change all our k with k plus 1. So again, copy first this part. So we have 1 cube plus 2 cube plus 3 cube plus ... plus k cube. Then after k cube, change this one with k plus 1. So plus k plus 1 cube equals, all the k on our right side of the equation will be changed to k plus 1. So k plus 1 squared times k plus 1 squared over 4. Next step, again, instead of writing the whole thing, 1 cube up to k cube, let us just change that with our right side of the equation, since in our assumption, the left side of the equation is the same with the right side. So copy this one. We have k squared times k plus 1 squared over 4. Next, copy plus k plus 1 cube. And then copy your right side of the equation. We have k plus 1 squared. And then simplify, k plus 1 is k plus 2. So we have k plus 2 squared over 4. Next step, look for the LCD of 4 and 1. We know that there is an imaginary 1 here. And the LCD of both is 4. So we have 4 divided by 4 is 1 times the numerator. So copy k squared times k plus 1 squared. Next, 4 divided by 1 is 4 times your numerator, that is 4 times k plus 1 cube. And then copy your right side of the equation, k plus 1 squared times k plus 2 squared over 4. Next, we need to factor k plus 1 on our left side of the equation. So the next step will now become k plus 1 squared times k squared plus 4k plus 4 all over 4. So copy your right side of the equation. Next, distribute and then simplify. So we have to get the factors of this one, that is k plus 2 squared over 4. And they balance with our right side of the equation, k plus 1 squared times k plus 2 squared over 4. Next, your conclusion. Therefore, the statement is true for all natural numbers n. That is how to solve our fifth example.